different fields in the TCP header. This is the segment structure, TCP segment structure. You can see the header fields and the application layer data we have covered in the last class. And we have mentioned that sequence number and acknowledgement number is used to synchronize between sender and receiver. We went through three particular examples, and also we have mentioned that there are some bits like A for acknowledgement, R for reset, S for SYN, and F for FIN. These bits are used for connection management, we will see today. And then another important field is receive window that indicates the free space in the receiver's buffer. So every time receiver sends an acknowledgement, it actually updates this receive window so that sender will know how many bytes free space are there. So sender will not send more number of segments that will overflow the receiver's buffer. So that is the purpose of receive window. Then we have seen these three examples. I am not going through very much details, but the first example was lost acknowledgement scenario. The second one, premature timeout. That means timeout is less, relatively smaller. So what happens? The acknowledgement is coming after the timeout. So sender has nothing to do but to retransmit the lost segment. And then the last one we saw is about cumulative acknowledgement, where we saw if earlier acknowledgements lost, but the latest one is received within the timeout, then sender will understand that receiver has received all the segments, so sender will not retransmit. Sender will send a new segment. So that is the idea of cumulative acknowledgement, advantage of cumulative acknowledgement. Now we will do some more examples today. So before going to the next topic, just first let us start with an example based on this third scenario. Okay, keep your paper and pencil ready. Just in this example, if I change the scenario, what is the change? Instead of acknowledgement 100 is lost, the first segment of data, that is sequence number 92 with 8 bytes of data, the data itself is lost. What will be the change in the outcome? You have to draw in your paper, and then you have to tell me what will be the acknowledgement number of the second segment by host B. So think, draw in your khata, and then give me only the acknowledgement number in the message box. You got the question? Any question from anybody? Sorry, Shahadat? I cannot hear you properly. Can you say it again? Yes. I have just closed the screen so that I can share in my tab. So I will show you hands-on. That's why. Let me share this screen. Okay, so
Sir.
Yes.
Sir, can you repeat the question again? I couldn't hear it because of the internet connection.
Okay. I am giving you the question in the screen. Uh, in the third scenario, right? In the third scenario, this was host A, this was host B, and then we have sent two segments. The first one with sequence number 92, right? And 8 bytes of data. And the second one with sequence number 100 and 20 bytes of data, right? That was in the question, in the scenario earlier. And they said the first acknowledgement is lost and the second acknowledgement arrived within the timeout. So suppose this is the timeout. So the first acknowledgement was 100 and the second acknowledgement was 120, right? It was the previous scenario. Now after the timeout, what A will do? Will A retransmit segment 1 or it will transmit a new segment? A new segment, because when host A received acknowledgement 120, although it did not receive acknowledgement 100, it can assume that receiver has received both. Okay, to understand this better, you can do one more thing. You can draw the buffer in the receiver side. Okay, so for example, maybe this is starting from 92 and this receiver has received this, then from 100 up to 120 receiver has also received this. Now as we saw, receiver has sent 100 here, receiver has sent 120 here. From the receiver's point of view, right, it has sent 120 for the second segment. Now from the sender's point of view, if you are the sender, what you can see? You can see only the acknowledgement. So host A did not receive 100, but host A received 120. And that is the use of cumulative acknowledgement. What cumulative acknowledgement say? It says that acknowledgement can never decrease. So if receiver has not received the first segment, it has received the second one, definitely there would have been a gap, right? In that case, if receiver did not receive the first segment, then this should be a gap. Everybody clear? Okay, in that case, the question is, in that case, what receiver will send? So that we have to first answer. That's why I have changed the scenario like this. Now think about this. Okay, just change the scenario like the number of data bytes that are same, but the first data itself is lost. Now change the scenario so that what I'm saying, the data is lost instead of the acknowledgement. Now my question is, what will be this acknowledgement number? Now definitely it will not be 120, right? Do you agree?
Yes, sir. So it will be 92.
It will be
92.
92. Any other answer? Yes, who has the question? Who has a question? Fazila. Who was asking the question? Right.
No, sir, I don't have any question.
Okay, you don't have any question. So Shahadat is saying acknowledgement, first thing, acknowledgement cannot be 120. Everybody agreed? Anybody disagree? Anybody has any other opinion? You can answer, no problem. Your answer can be wrong, no problem. We need to understand the situation.
100 hor to kena.
Yes, good, Priyabroto, Jahid and Priyabroto, you actually introduced the question. I was expecting that it should have been 100. Okay, for answering that question, did host B receive sequence number 92 segment? Did host B receive that? Yes or no? First.
No, sir.
Yes. No, right?
No, sir.
So
No,
if it
sir.
did not receive sequence number 98 byte of data, how can it send 100? So 100 is out of syllabus. Why? Priyabrata, are you
Yes, sir.
clear about that?
Yes.
B did not receive that segment. If it did not receive the segment, how can it send acknowledgement 100? So 100 is out of question. Now the question is whether it will be 120 or it will be a separate one. So it will not be 120. All of you are agreed, right? And then Shahadat is saying
120.
92. Do you agree with that? Do you agree with that? 92, everybody, or you have different option? So 100 cannot be 100. Acknowledgement cannot be 100. That is for sure. Now, how can you understand this? Just think about if I redraw this. If I redraw this, then it will be better. Okay. Again, this is the buffer of the receiver. Now receiver did not receive 92, right? That means there will be a gap. So from 92 to 100, there will be a gap. Everybody agrees, or anybody has different opinion?
Yes, sir.
Okay,
Agreed,
so
sir.
second segment, right? The second segment is received, right? Now, unlike go back end would have been discarded this, right? But select to repeat stored that. But we are now going through TCP. So you can see that TCP actually now takes the property of selective repeat, not go back end. In other case, we'll see TCP taking property of go back end also. But in this case, TCP will store, will not discard. So like selective repeat, TCP will store here the segment, but there was a gap, right? After the gap, TCP will store up to 120, but there is a gap between 92 and 100. Now the question is, what will be the acknowledgement number sent by host B in this case? You can answer, you can give answer in the message box. Please answer your, it's just a value. It can be wrong, but put your answer in the message box so that we can debate. We can actually discuss, because Shahadat has answer. What is that, Shahadat? 92, right? Oh, Shahadat is saying it is 92. Is there any other answer? Anybody? Anybody? I did not receive any answer yet. It should be. You should at least give some answer according to your choice. Priyabrata? Jahid? No answer? Definitely it will give either 120 or 92. It cannot give 100. Right? You can see the diagram. So it must be either 120 or it must be 92. It cannot be 100. Agreed, everybody? Because in case of 100, it must have received 92 to 100. Okay, if you send Shahriaz, Imam, Reza, good. I want answers, even if that is wrong, even if that may be some confusion. If you give the answers, I can discuss it. Will be much more clear to you. Jahid, you are also saying. So I got 3 answers, all 120. I agree with you. Since receiver is receiving 100 to 120, so receiver can send 120, but that is against cumulative acknowledgement. Just think simple. If sender receives 120. Is there any way for the sender to understand, to decide whether or not receiver has received the first segment? Is there any way?
No, sir.
Think. No, there
Sir,
is no way
sir,
sender
is
will
it
know that, okay, some segment is lost. Yes, Shahadat?
স্যার এটা কি অ্যাকনোলেজমেন্ট নাম্বার কি 112 হবে?
Same acknowledgement number?
112 since we lost 8 byte.
Sorry, Shahadat, can you, I think your mic is creating some noises, so you can ask your question in the message box, then it will be better. So if sender B sends 120, there is no way sender A can decide on the first segment whether it is received or lost. There is no way. So that is the problem. Those who are giving 120, did you get my point? Okay, Shahadat is asking, will it be 112? How 112 can be? Okay, if you add 20 to 92, then it can be 112. Actually, the answer is no. Okay, let me make it clear. If you see the diagram I have drawn, there is a gap. Remember, in case of go back n, if some segment is lost, then all the other segments are out of order, right? For all out of order segments, go back and discarded the segment and sent what? Last in order acknowledgement, right? Can you remember? Last in order acknowledgement. So in this case, what is the last in order acknowledgement other than Shahadat? What is the last in order acknowledgement in this case? Anybody?
92, sir.
So 92.
Very good. It's 92. Right, it's 92. Now make it clear. If B sends 120, as you say, then it has no way to know that the first segment was lost. If B sends 92, is it possible for A to decide that the first segment was lost? Yes or no?
No, sir.
No, sir.
No or yes? Because A is receiving 92, that means A knows I have sent two segments, one from 92, one from 100. It is saying me 92. 92 is before what? Before the first segment was sent. So 92 was the last in order acknowledgement. So if it receives 92, definitely A can know that the segment starting from 92 was lost. Is it clear?
Yes, sir.
Okay, the answer will be, now let me write down the answer, then think whether it is clear or not to you. Why 92? The same thing. Now TCP property is common to go back and. Go back and says is if there is any loss, if there is any gap, for all subsequent packets, send the last in order. Same thing here. If there are one or more gaps, all the subsequent segments received by the receiver will send the acknowledgement without any gap. Without any gap. What is that acknowledgement? If we assume that the previous segments are all acknowledged, then that is 92, right? Any question? Now, if in this case, sender A receives 92, sender A will be sure that the segment starting with 92 sequence number is lost. What sender will do? What will be the change? The change will be now sender will retransmit the segment with sequence number 92 and 8 byte of data. So sender will retransmit because sender now is sure definitely the first segment is lost. How sender is sure? Because sender received 92. If sender received 120, Is it possible?
No, sir.
No, it's not possible. Sender cannot decide. That is the problem. So this is called cumulative acknowledgement. Cumulative means why receiver is sending 92? Because there is a gap. In the previous case, where data is not lost, acknowledgement is lost, receiver sent 120. Why? Because there was no gap, right? So
Yes.
if there is any gap, in that case, the only way for sender to decide is acknowledgement. The only way. I have several times I have specified this. Sender will never see the state of receiver. Sender cannot see anything from the receiver other than the value acknowledgement sent by the receiver. So only using these acknowledgement numbers, sender must logically decide which segment is lost. And sometimes it might happen that we saw some segments might be retransmitted redundantly. We cannot do anything about that. But in this case, see, in the previous scenario, that was earlier scenario. What was the earlier scenario? Let me draw it again. Earlier scenario was like, let me draw it in a brief. The acknowledgement was lost, but the second acknowledgement was received. Then after the timeout, no retransmission. It was transmitting the new data. Okay, but no retransmission was happened because in this case receiver has sender has received 120, and by 120 sender is sure that receiver has received both. Why? Then you see this scenario. In case the first segment was lost, receiver cannot send 120. Receiver must send 92 according to cumulative acknowledgement. So this is the idea of cumulative acknowledgement. And then this is actually an advantage for TCP. Now my last question, what will be the acknowledgement number here? What will be the acknowledgement number here? Write in the message box. Don't say it. Just write down in the message box so that I can see your answer. Shahriaz, you said 100. The answer, okay, let me see what others think. Is there any other answer? Shahadat 120. Any other answer? Please participate. No mark will be deducted if you give me wrong answer, but that will help us to discuss. One thing is clear, the choice is either 100 or 120. I got 220, I got 400 answer here. Others, what do you think? Fazila 120, Imam 120. Okay, but many of us still think it's 100. Okay, those who are giving answer 100, they have some logic, because we sequence number is 92 and data is 8 bytes, so 92 plus 8 is 100. You are correct in the basic sense, but you are not correct in this scenario for cumulative acknowledgement. When you say cumulative acknowledgement, just think about receiver's buffer. When this retransmission happened, what will happen? Receiver's buffer gap will be filled up, right? So the question is, when the gap, any gap, 1 gap, 2 gaps, 3 gaps, when the gaps will be filled up, what will be the acknowledgement number? Will it be just this one, or will it be the updated one? That is the question. What your logic says. What is logical?
Updated one, sir.
Very good, updated one. Because there could be a gap and there could be like 4 segments stored after that. Do you need to acknowledge each one of this after the gap is filled up? or you can send one acknowledgement, update acknowledgement, that will inform the sender that all the subsequent segments has been received without any gap. Definitely it is better. So that is the logic. See, we are always working as an engineer, we are always working with logic. So don't see all the theory just as theory. Apply your own logic. What you will do, what is better, what is efficient. So that is the example with cumulative acknowledgement. TCP uses it for advantage. So if there is gap, doesn't matter how many segments it has stored after the lost one, it will always send the last in order acknowledgement. That is the last acknowledgement without any gap. In this case, it will not be last in order. It will be last acknowledgement without any gap. And whenever that gap is filled up, when it is filled up, when sender will send the lost segment, then it will be filled up. When it will be filled up, receiver will send the most updated acknowledgement, because acknowledgement field can contain only one value. So Tahmina, Rohim, are you clear now? Imtiaz?
Yes, sir.
Yes. So if you, once you are clear, I think it will be for any case, it should be, the logic should be the same. If there is any gap, send the previous one. If the gap is filled up, send the most updated one. Don't go for the middle ones. Okay. Any question from anybody? Okay. If no
স্যার একটা কোশ্চেন
question,
ছিল স্যার।
yes, sure.
স্যার এখানে যদি সিকোয়েন্স আরেকটা থাকতো স্যার, সেক্ষেত্রে অ্যাকনলেজমেন্ট কত হতো?
Okay. Shahriyaz, I am coming to that. Now I am giving you one scenario you have to solve. You have to solve, and then you have to give your answer in the message box. Okay, these are all numbers, so it will not be a problem. Okay, the scenario is like this: A and B again, and A is sending, for example, segment 1, then segment 2 is somehow lost, segment T is received, then an acknowledgement is sent, acknowledgement is sent, and the timeout. So there is a timeout, for example here, and after the timeout, sender is sending, retransmitting a packet, and then the acknowledgement is coming. Okay, now let me put some variables here. So for example, the first sequence number is X, and it contained 100 byte of data. Second sequence number is for example 600 Y byte of data. Third sequence number is 750 and 50 byte of data here, sending 50 byte. Then XY, so first acknowledgement number will be Z, and then the second acknowledgement number will be P. Then after the timeout, then a sequence number will be sent as Q, and then after receiving the retransmitted value, the acknowledgement number will be R. So now you have to tell me value of X, Y, Z, P, Q, and R. I think if anybody understands this example fully, he or she will understand the all previous scenarios very clearly. So please participate. You can draw in your paper with pen and pencil, and then give the answer. Don't do it just out of head. Do it randomly, and then give random answer. Do it in your paper and pencil, and then give the answer You don't need to like x equals to this, y equals to this, z equals to this. You can give answers in parts, no problem. You don't need to give all 6 at the same line. So I suggest everybody, please take some time. I am giving you 3 minutes. Okay, so 12:46 is now. I will discuss at 12:49. By the time, if anybody has any question, you can ask me. Okay, Riaz, you found x as 500. I will confirm the correctness after 3 minutes. Okay, after now 2 more minutes, but you can give your answers by this time. See, this type of examples, if you participate with me in the class, I think it will be 80% clear in the class. If you go back without participating in the class, it will take much more time, and it cannot reduce your confusion. So please participate in the class. I am giving enough time for you, but if you don't participate, then it will be not that effective. Okay, I think time is up, but I did not receive many answers. Yes, Riaz, you found x equals to 500 and y equals to 150. I think Riaz is correct. Since host A, the sender is sending 3 segments at a time, that not at a time, one by one, back by back. Shahadat x 500, y 150, z is 600, p is 600. Yes, correct up to this point, and then q and r. So it is very simple. See, since x y 600 is sending after x, that means if you add data with x, you will get 600, because sender will always send in sequence. Yes, Enam, I think p cannot be 500. You have one wrong answer here, and q cannot be 600 also. Okay, let me just give the solution, and then you can clear your confusion. So since sender will always send sequential, so you can say like x plus 100 equals to 600. That means x equals to 500. Simple. Then 600 plus y will be again 750. That means y will be 150, right? Now z will be the acknowledgement for the first one. We got the x now. So Z will be X plus 100. That means 600. Now, the second segment is lost. So after receiving the third segment, we have just seen an example that if there is a gap for any other subsequent segments, acknowledgement will remain the same, right? Sorry, this is P. This is not Z. So P equals to 600. And then after the timeout, can you remember? I have mentioned in the last class, TCP uses one single timer. So after the timeout, what TCP will do? Anybody? Which segment will be retransmitted? The oldest segment that is not acknowledged.
600.
Right, 600. Because the oldest segment now, 500 with 100 byte data already acknowledgement received. So what is the oldest segment? The second one. So second one will be retransmitted. That means Q will be 600. Q will be 600. And finally, what will be the acknowledgement?
800, sir.
800. It will not
800.
be 750. It will be 800 because again the updated one. So this is the correct answer. Now, if you draw the diagram, if you draw the buffer of receiver, it will be clear. For example, it first received 500 to 600, no problem. But then there was a gap from 600 to 750. Then the 750 to 800 was again received. So after retransmission, this gap was filled up. When this gap was filled up, then it will not send this one. It will send the updated one. So what is the updated one? That is 800. Now, is there any question? Anybody? So just every type of situation we have brought in this example. So if it is clear, then TCP is clear to you. Now, there are some parameters you will find in the exercise or in other cases. First one, there is a variable called send base. There is a variable called send base. So send base actually stores latest acknowledgement. So send base is a simple variable like ABCD. You have used integer A, right? Integer B. So send base is like a simple variable. It always stores the updated acknowledgement. So whenever we don't know what was the previous one, but whenever it receives acknowledgement Z is what? Z is 600. That means in this point, send base will be what? Simple. Send base will be 600, right? When P is received, what will be the send base? What will be send base here?
600.
Still 600 because no updated data. So it will be previous. Now see, whenever a sender receives acknowledgement P that is 600, it knows this is duplicate, right? So this is called duplicate acknowledgement because it was already received. And now a duplicate acknowledgement means what? Some segment was lost, right?
Yes, sir.
Definitely, simple logic. So this will mean we have to decide, and we will we will go to another protocol just after this. In that case, send base will be very important. And then you will see another keyword, that is MSS. MSS is maximum segment size. But in our case, MSS will not make any difference. Maybe in the question it might say MSS equals to 512.1024, but that actually doesn't affect our result. but we might need send base. And another thing is the free space at the receiver's buffer. So whenever receiver receives a segment, every time it will calculate this free space. So this is actually receive window. Okay, so to find the receive window, you need to know the full buffer size. For example, if again I draw this one, like if I say, okay, this is the receive buffer, this is the full buffer space, and for example these are occupied data, then you can say these are occupied space. Okay, occupied space. That means what? That means this will be the receive window, right? So this is the free space. Every time sender will give feedback, sorry, receiver will give feedback to the sender, and in every feedback receiver will give this value of the receive window for the sender to know that how many bytes I can send without waiting for next acknowledgement. So that is actually flow control. Okay, so using this example, we have actually learned many things. If you are clear the logics here, then in any scenario, I think it will not be a problem for you. Any question from anybody?
Can you repeat the last part, please?
Shahada, can you ask your question in message box? I think I don't know why it's creating a noise. I cannot hear you properly. Just ask your question in message box. Anybody has any other question? Okay. Last part about flow control. Okay, we will see flow control shortly. Don't worry. It will be in there is a section called flow control. I will go through that using the slides. So in that case, it will be clear, I think. So this ends our hands-on example. Let us now go back to our lecture. So if anybody has any question, you can feel free to ask. For the time, for now, just there are some examples and exercises in your workbook. We will do one or more in the next class, but you can go through those, and then if you have any question, we can discuss for some time in the next class. But for the rest of the class today, let us progress with some other theoretical concepts. First one is TCP fast retransmit. So until now, the only way for retransmission was timeout, right? And as I say, timeout is a dynamic value. It depends on the round trip time, and round trip time depends on the condition of the network. So if the condition of the network is very good, maybe data transmission time will be less. But the problem is, you can see in this diagram, between host A and host B, there can be many number of links, right? So you cannot, host A, it is not feasible to know for host A or host B about the entire situation in the middle. So what can happen when an end system decides on a timeout? Maybe that can be too short or too long, because when it decides a timeout, calculates a timeout, it uses a formula based on RTT, and network condition can suddenly change. It can be suddenly better, it can be suddenly worse. So what can happen? The calculated timeout may be much shorter than the realistic scenario, or much larger, much longer than the realistic scenario. If it is much shorter, we have already seen premature timeout. What happens? The acknowledgements mostly will come after the timeout. What will be the problem in that case? Anybody? If timeout is shorter than the real, in fact, practically it is not possible to estimate the real case, because there can be so many links in the middle, so many nodes in the middle. So end system can only predict. So if it predicts the timeout shorter, what will be the problem? We have already seen some example. What will be the possible problems? Okay, acknowledgements will come after the timeout, right? It will happen frequently, and in that case, what will be the problem? Sender will unnecessarily retransmit segments. That will be problem if timeout is shorter. If timeout is longer, then what can happen? In that case, if the data itself is lost, acknowledgement not lost, then sender will wait for longer time. That will create a slow response. For example, you can see here, suppose this timeout is longer. What happens? Host A sends 5 segments back by back. The first segment correctly received, the second segment lost, and the next 3 segments correctly received. But one problem with the receiving end is that if it uses reliable protocol like HTTP or SMTP based on TCP, then if there is any gap at one segment is lost, then it cannot produce the data for the application, or data cannot receive the application. Application cannot receive the message. That means whether it is an email or a file, if there is any gap, application will not receive the message. If application does not receive the message, then the problem is what? The buffer, the memory of the receiver transport layer will not be free. If the receiving transport layer memory is not free, the window size will be less, or even can be 0, no space in the receiver's buffer. What will be the problem? Sender cannot send data in a more larger rate. So these are all related. Now, if in this case host A waits until the timeout, what will be the problem? Response will be slow, because the data second segment is lost. We know it is lost, but sender will not know until timeout is over. So in this case, there is a second option. It is called fast retransmit, because it works fast. That means if sender receives 3 duplicate, exactly 3, not less than 3, not more than 3, duplicate acknowledgements at some point, even before the timeout, sender will retransmit the segment. That will save time, that will reduce delay, like this. The first segment, acknowledgement will be 100. The second segment is lost. For all subsequent segments, acknowledgement will be 100. Is it correct? Because if there is any gap, receiver will send the acknowledgement before the gap. Already we have solved a problem for this. So the second 100 will be first duplicate, right? Then how many duplicates are here? 3, because the first one was original, acknowledgement 100, and then next 3 duplicates. So if sender receives exactly 3 duplicate acknowledgement, what sender will do? See, receipt of 3 duplicate acknowledgements indicates 3 segments received after a missing segment. Lost segment is likely, so it will immediately retransmit the data without waiting for timeout. Definitely, in some cases, especially like wireless network, like our cellular network, where there can be some blind spots. Momentarily, network connection becomes weak, but maybe the overall situation is good. So in this case, waiting for the timeout will actually slow down the progress. So fast retransmit can be used here to save this time, and it was experimentally shown that if we retransmit after exactly the third duplicate, if you retransmit after 1 second, sometimes what happens, maybe data was not lost and acknowledgement was actually delayed. So if you retransmit after the first duplicate, it will create more and more duplicate retransmits, okay, unnecessary redundant retransmissions. So that's why from experiment they have found that if you retransmit exactly after the third duplicate, then okay, then it will be better. Any question? Anybody? Clear? So this is called fast retransmission. That means even before timeout, we can retransmit if we receive 3 duplicate acknowledgements. So this is the second option for retransmission. Previously, in all other protocols, the retransmission was only after the timeout. So some TCP protocols, some TCP versions supports this fast retransmit, some do not support. So it's not mandatory. Clear? So this is the fast retransmit. Now second point, flow control. I have already shown you hands-on, but there is another illustration how flow control is done. So after receiver receives the packets from network layer removes the header, it received by transport layer as segments, and then it stores in the buffer. You can see in the blue box, that is actually the buffer. So each segment is received here, and then when application removes the data, application will only remove the data if it receives all the segments without any gap. That was I was talking about. And after application receives the data, then the memory buffer will be free. Okay, otherwise it will be a problem, like too much data for the receiver to handle. In that case, data will be lost. And this is controlled by receive window. Already we have shown that. And how this is calculated, see here it showing. So the entire buffer is the receive buffer. If you can see here, the total size is the receive buffer. Then the blue shaded area is the buffer data, that is the segments already received. And the off-white part, or the very light colored space, this is the free buffer space. And this free buffer space is calculated by the receiver as receive window, and then sends the value in the reply, in the acknowledgement. So when the sender receives this value, sender will know I cannot send more than this amount of data. So this is called TCP flow control. Okay. Clear? So that is about flow control, how receiver calculates the free space. Then another concept, that is the connection management. As we have mentioned, that any application layer protocol that uses TCP must establish a connection, then transfer the data, and then at the end definitely must close the connection in a decent way. So TCP three-way handshake is the initial connection steps, It must be completed before data transfer between the application. So there are 3 steps. The first step, as you can see, a segment is sent by the client, that is our browser. It sends a segment where the SYN bit is 1. I have told you during the header description, there are some bits. Those are used only in special cases. One case is connection establishment. So the SYN bit is only 1 when an end system sends a segment for a new connection request. So if the receiver receives a segment with SYN bit equals to 1, then it understands that this is a new connection request. Then, for example, this is a server. Then server will send an acknowledgement. That means it will create a segment in the second step. See, the SYN bit is still 1, and the acknowledgement bit will also be 1. In the first segment, you can see the sequence equals to X. That means the client will choose an initial sequence number. As you can see, I have told you that it will create a random number, randomization function for security reason. So it will choose an initial sequence number X, and then it will include in the message to inform the server that, hey, I have started my byte numbering with X, and I want to create a connection with you. Similarly, server will start its own, it is listening in a particular socket, and whenever a request comes, it creates some buffer, it creates its own sequence number. When server will send data, it will send from its own sequence number. Client sends data, it will send from its own sequence number. So both has different sequence number. So server creates a new sequence number Y, and it acknowledges the sequence number X from the client using X plus 1. Still no data is going, only the segment with header. Now in the third and final step, it says established. Established means now the connection is established, and by the third state where sender sends a segment, acknowledgement segment to the receiver. Receiver is server here. Acknowledgement is 1. Now see, the SYN bit is no more 1. The SYN bit was 1 for the first 2 steps, and for all subsequent cases, SYN bit will be 0. There is no other use of SYN bit. So acknowledgement number will be Y plus 1 from the previous step. Now see, both client and server established a connection. All the scenarios we have already discussed hands-on actually after this connection establishment. So we assume that connection was already established. Then we have shown you the data transfer using sequence number and acknowledgement number. Is it clear? Any question? So for every application using TCP, first this connection must be established, then the segments will be flowing from one side to another side with the help of synchronization using sequence number and acknowledgement number. Okay, now suppose our data transfer is complete. Again, the connection must be closed in a decent way according to the protocol. So this is called closing a TCP connection. In this case, again, client initiates the connection that I want to close the connection. Now see, the FIN bit is 1. So this is another bit that is used only during closing the connection. Server sends an acknowledgement saying that, okay, I have received your request, but I have opened up many database files, many other files. Let me complete my works first. Then we should close. So it will send the acknowledgement and it will do its own housekeeping works. These are called housekeeping works for the server, because server has opened many databases, many files, and many connections already there. So server will close all these, and then in the third step, server will send a FIN segment, again FIN bit 1, saying that, okay, I have closed my responsibilities. Okay, now you can close the connection. It sends the server client Now client sends an acknowledgement, and after sending the after server receive the acknowledgement, server will close. See, the state has closed, but client will close later on. Client will wait for some time. This is called timed wait for 2 into maximum segment lifetime. Why? Because the acknowledgement, last acknowledgement may be lost. So server will wait for acknowledgement. Server cannot close. So that's why client will wait for some time. That amount of time by which, if the acknowledgement was lost, server will have the timeout. So server will send the fin segment again. If client did not receive the fin segment again by this time, then client will close the connection. So this is again logical. Both sides must close in a decent way. That's why closing a TCP connection also must follow these 4 steps. So we have seen connection establishment, three-way handshake. We have seen many examples of data transfer using sequence number, acknowledgement number before. And now we know how a TCP connection is closed using different steps. So these all represents the TCP connection establishment. Any question? Okay. Okay, then we have come to the last section of chapter 3. We will do some examples in the next class. Just let us go through the theoretical points. Now, we know TCP is a reliable protocol. TCP is a connection-oriented protocol. We also know TCP does control the flow of data. We have already seen using window, receive window. And the last algorithm or control TCP does is congestion control. So before going to the congestion control, you have to know the difference between flow control and congestion control. See, the flow control only is done based on receiver's space, nothing else. We don't know how many links are in the middle, what are the capacities of the links, how many users are using those link capacities. Only receiver's buffer is known as receive window. So sender will ensure sender is not sending more number of segments that will overflow receiver's buffer. But what can happen? Receiver's buffer can have a larger space, but the intermediate links might be the bottleneck. The intermediate links might have a very low capacity. In that case, what will happen? Receivers packets will not reach up to the receiver because those packets will be lost in the middle in some router because the buffer is low. Maybe capacity is very low. When capacity is low and packets are coming in a rate more than the capacity, what will happen? Packets will be lined up in the queue. Where? Maybe in the intermediate routers. In the queue. Queue means memory. Then after some time, the memory will be full because memory is limited. Then what will happen? The extra packets will be lost because there is no space in the memory. It could be in any of the intermediate routers. So it is not reached the final receiving end. So there is another issue called congestion control that not only takes input from the receivers or senders, that also takes input from all the participating nodes, the data they are sending, the capacity in the intermediate links. So we can define congestion. We all know congestion, that is traffic jam. If number of cars are becoming more and more in a particular road, in anywhere in the world, then the traffic, if traffic is more, then we call it a traffic jam. That means the road is occupied by more number of cars, maybe for several reasons. Similarly, when huge number of packets are actually piled up in queues, in lines, in intermediate nodes also, or in the end systems, this actually creates a congestion. So the definition can be informally too many sources sending too much data too fast for network to handle. But this capacity is not the receiver's capacity only. This capacity is the capacity of intermediate links and intermediate devices. What can be the problem with congestion if we do not do congestion control? Delay will be long, definitely. Even if we increase the buffer size in the routers, space in the buffer, the delay will be much larger. And also, even if we increase the buffer size is limited, memory is limited. So after the memory is full, then the packets will be lost. So this can happen. So definitely we have to control the congestion. Who will control this? TCP can control this, and it is one of the top 10 problem in the world. So how this is actually controlled? You can see this can be controlled by end system. You can see the end system in the both side, but there can be multiple routers in the middle. So there are two types of congestion control. One can be end-to-end. Normally, what transport layer does, end-to-end congestion control. There is no explicit feedback from the intermediate nodes. We don't know where the packet is lost, in which router, in which link. But the receiver will inform the sender that I did not receive that packet. The sender will know my packet is lost. Doesn't matter in which router, in which part of the intermediate part packet is lost, but it knows the packet is lost. When it knows a packet is lost, then it will just decrease its own transmission rate. That's it. So that is end-to-end congestion control. It only works on observed loss or delay. If delay is much more, then lower the rate. If packets are lost, then lower the rate. So that is the idea. Approach taken by TCP. Then another one can be network assisted congestion control, although we are not covering that. In this case, routers provide the direct feedback to sending or receiving hosts with flows passing through congested router. So a router can say, okay, don't send packets to this link because this link is congested. So intermediate routers will send the information, because router works in network layer. This is called network assisted congestion control, but this is not our case. We will not cover this like this. Okay. Some protocols like TCP, ECN, ATM, megabit protocols, but this will not be covered in this course. We will mainly cover TCP congestion control, how TCP controls the congestion. And in this case, there are three fundamental primitive approaches. The first one, AIMD. AI for additive increase and MD for multiplicative decrease. Okay, before I go to these approaches, the common thing in TCP congestion control is what? If you get loss, you get the packets, you send packets are lost, a node, one particular end system, then that end system will decrease the rate. But decreasing the rate means your speed will be less. So whenever there is no loss, you should increase the rate. By this way, any node will try to get the idea about the network condition. So it is a continuous process. If there is a loss, decrease the rate. If there is no loss, increase the rate. If there is no loss, increase the rate. So no loss, increase the rate. Loss, decrease the rate. The question is how much you will increase and how much you will decrease. That is the question. Based on that, there are three approaches. So additive increase tells us that always increase sequentially. So if you send one segment in one RTT, there is no loss. Then in the next RTT, send two segments, no loss. Next RTT, send three segments, no loss. Next RTT, send four segments. But if there is a loss, decrease your rate. That means how many segments you will send in the next RTT? It will be n by 2. That is called multiplicative decrease. So additive increase means increase by 1, but multiplicative decrease means decrease by half. So whenever there is a loss, suppose the current rate is n, make it n by 2. So that is AIMD. And if you follow the trend, it is like a sawtooth. You know sawtooth, korat, right? Kat katar jonne korat. So it's a sawtooth behavior. Why it is sawtooth? Because if there is no loss, increase the rate. If there is a loss, decrease and make it half. In case of decrease, don't make it sequential, because if you just remove one car at a time from the road, jam will take long time, right? So what we do, we just reroute the vehicles from the previous intersection so that jam becomes controlled in a reasonable amount of time. So same thing here, when you decrease, will decrease multiple. That means it will create half. So that is AIMD. But one problem with AIMD is definitely there is a theoretical peak. Practically, it is not possible to know what is the theoretical peak, possible rate, possible optimal rate. That cannot be calculated directly. But we can probe by increasing the rate. But if we increase one segment at a time, it will take larger time to reach that theoretical peak. So that is one problem with AIMD. Then there is a second one. I'm skipping this for now. There is a second one that is called slow start. Slow start solves that problem of reaching the peak, taking a long delay to reaching the peak. Slow start says, okay, you will start from one MSS at a time in 1 hour. But if there is no loss, don't increase sequentially, increase exponentially. How? In the first RTT, send one segment, no loss. In AIMD, in the second RTT, we send two segments, right? 1 plus 1. Here also we send two segments. In the case of third RTT, we set 3 segments, but here 2 to the power 2. So 4 segments. In case of 4 RTT, if there is no loss, then 4 will be doubled to 8. 8 will be doubled to 16. 16 will be doubled to 32. So it will be exponentially increased to a particular peak. So what is the advantage? It will take very small amount of time to reach the peak. That is the idea of slow start. But again, slow start has one problem. If you increase exponentially, sometimes it might be 64, 32 to 64, then 64 to 120, 120 to 250. So the jump will be so high in one particular RTT, maybe huge number of packets will be lost. It can happen if it is over the theoretical possible peak. So the slow start has that problem. Then finally they have the third option, that is slow start with congestion avoidance. What it says, let's set up a threshold. So up to the threshold, go exponentially, but after the threshold, go sequentially. So it basically joins AIMD and selective, AIMD and slow start, combines both. And in case of slow start and in case of this third one, when a packet is lost, then the idea is, if the loss is due to timeout, now see we have two options. One is retransmission for timeout, one is retransmission due to 3 duplicate. Can you remember? First retransmit, after 3 duplicate, we can also retransmit. So 3 duplicate actually indicates better network condition. So in case of timeout, we will go back to again 1 MSS per RTT. In case of 3 duplicate, we will just make it half. So it depends on the type of loss. If the type is timeout, it again go back to 1 MSS. That is from 1. If it is because of 3 duplicate, then it will become half. So these are the 3 approaches used for congestion control by TCP. And also there is a simple formula of changing SS threshold. Whenever a loss is occurred, SS threshold always will be just half of the last rate, last available peak rate. We will do some hands-on examples in the start of next class. Just you can go through the theoretical concepts, and then when we do some hands-on, it will be much more clear. Any question in these congestion control mechanisms? Anybody? So that is end of our chapter 3. In the next class, we will do some hands-on examples. But other than that, we have covered all theoretical concepts in chapter 3. Do you have any question, anybody? No?
Sir,
Yes.
so have we started the final syllabus?
I don't know yet. I don't know yet, but you just try to understand. That's why I am suggesting you to participate in the class, because maybe when we get the instructions, because we are still not sure what will be the way of final exam. Is it physical? Is it online? What will be the idea of containing the syllabus? We will get the instructions, then we will do accordingly. But as I said, always, I always try to not to actually do it very painful for the students. I try to minimize that. So just maybe I will pick the important concepts that we have covered in the class, that we have solved many examples in the class. So that should not be a problem for you. But let us wait until we get the specific information. But by up to that time, please don't just go go through without practicing. In that case, what can happen if you don't practice the important things? It is not like just only 2 chapters. Okay, last 2 chapters will be the final syllabus. It could be like this. These are the important topics from each of the chapters, and we have to cover this. But in any case, as I said, don't be panic, don't be afraid, because I will do something that will be manageable for all of you, if only if you are with me in the class. Okay, so don't worry about that right now. We will decide later. But definitely the things will be selected from the class that we have covered very much hands-on.
Sir,
Okay.
how many class tests you will cover?
There is no concept of class test now. We will take some in-class
Sir, that means
assignments.
in-class assignments. Sir.
Right,
How many
in-class
in-class assignment you will take?
Actually, I have taken 2, right?
So
okay.
officially maybe 1, and next and second one is you just practicing
Okay,
in our
from
class
now
and
on,
then
from now
give
on,
us a question. to
okay,
answer
from
that.
now on, just take preparation. When we do some hands-on, I might take the same day assignment. Why? The reason is this. The reason is I want you to participate in the class. And there are options, no problem. But I want you to participate with me. So if you understand in the class, why not? I will give you very simple question. It depends. I can give you like questions, 3 or 4 questions. I can give you 1 or 2 questions. So it depends on it. It does not depend on, okay, I have to announce earlier, then I will take after 1 class. I can take in the same class. So take preparation for this. So that's
Okay, sir,
why.
understand, sir.
Yes. And but next class I will take 1. I'm just informing you. Next class I will take
What will be the topic, sir, then?
Okay, topic
Sir.
will be just TCP. Just TCP. TCP.
Okay, sir.
TCP that only TCP section 3.5. So it will not be, mostly it will be hands-on question. It will not be theoretical question. So
next class means Wednesday.
right, Wednesday, right. See,
That means,
all
sir,
the
you will
things
give
we have
you will give us some questions, and we have to answer them.
already. You got the questions already. I have solved some questions in the class, right? These
Yes,
are
sir.
simple. These are simple questions. And also you have some examples in your workbook.
স্যার নেক্সট
Similar-
ওয়েডনেসডে তো
similar
স্যার
example.
Only TCP
পয়লা
means,
বৈশাখে ছুটি থাকবে স্যার।
section 3.5.
Oh, Wednesday is holiday.
ইয়েস স্যার।
Okay, in that case Sunday. In
Okay,
that
sir.
case, but next class, next available class, there will
Sir,
be in
just
class
section
session.
3.5.
Right, section 3.5 only. Okay,
Sir, how many home assignment you will give us?
One more.
We just
One more.
covered one home
right.
assignment, sir.
I will give one more. So there will be two, and both will
sir.
be counted.
Okay, sir.
Okay.
Yes, sir.
Okay, let me take the attendance first, huh? Abdullah Al Rifat,
Yes, sir.
Enamul Haq,
Present, sir.
Imam Reza,
প্রেজেন্ট স্যার।
Rokonut Jaman,
ইয়েস স্যার।
Laila Ishrat,
Chillo, sir.
she was there. Okay. Farah Farzana, Fazle Rabbi,
ইয়েস স্যার।
Priyobroto,
Yes, sir.
Ifat Rafsan,
Yes, sir.
Ali Ahmed,
ইয়েস স্যার।
Kaushik Devdas,
Yes, sir.
Khurshida Jahan,
Present, sir.
Samir Ahmed,
Yes, sir.
Mahmudul Hassan,
প্রেজেন্ট স্যার।
Fahim Shakil,
Present, sir.
Abu Sajjad Ankon, Nibirud Jaman, Sadman Shakib, Adnan Kobir,
Yes, sir.
Taki Yasir,
Present, sir.
Shahadat Hossein present, Rakibul Islam, okay, Al Shahriar,
Yes, sir.
Tanvir Hassan,
ইয়েস স্যার।
Shakib Hussain. Please mute your microphone. Mashuke Alam,
Yes, sir.
Sabbir Sarkar,
Yes, sir.
Abrar Sadiq,
ইয়েস স্যার।
Ishtiaq Ahmed, Ishtiaq,
Present, sir.
okay, Mufail,
ইয়েস স্যার।
Mahfuzur Rahman Sifat,
Yes, sir. Yes, sir.
okay, Shafiqul Islam,
Yes, sir.
Amanta Hussain,
Present, sir.
Abir Reza,
প্রেজেন্ট স্যার।
Khondokar Jahidul present,
Yes, sir.
Khalid Ridwan,
Yes, sir.
Shahariaz present, Tahmina,
Present, sir.
Muhammad Mahfuzur Rahman,
Yes, sir.
okay, Fazila present, Ashrafun present, Shifa Chaudhuri,
Yes, sir.
Misbahul Alam,
Yes, sir.
Yasir Arafat,
Present, sir.
Sudeep Sarkar,
প্রেজেন্ট স্যার।
Abdur Rahim, sorry,
Present, sir.
Miraj Farooq,
ইয়েস স্যার।
okay, Abu Abdullah, Khondokar Shravan, you were there, right? Shah Alam,
Yes, sir.
okay, Shah Alam present, Khondokar Shravan present, Imtiaz Hussain,
প্রেজেন্ট স্যার।
Rifaz Nahian, Kamrul Islam,
Present, sir.
okay, Dihan Pathan,
Present, sir.
Abu Kibriya,
Yes, sir.
then Bidhan Chandra,
Yes, sir.
and Shakawat Hussain.
Present, sir.
Okay, thank you very much. See you in the next class.
Sir,
Yes.
will you add any part of mid in final term?
No. Any part of mid means the syllabus, about the syllabus.
Yes, sir. Yes, sir.
That's what I am saying. It can be some important part, since we are not taking any class test, any midterm. So maybe I will pick the important sections, maybe from each chapter, not entire, and that might be included in the final. So it's not all about the size of the syllabus, it's the importance of the syllabus. Okay, and the size
Okay,
should
sir.
be manageable. I will inform you. Okay, no problem.
Sir, another question is,
Yes.
you did a homework in the previous class.
Right.
Will it consider as
Okay,
in
a
class
normal
assignment?
in class assignment, right? Okay, okay, fine. Actually, from now on, I have already announced this. I can take in any class. That the way will be, I will do one particular example hands-on, so to make you participate in the class. That is my goal. So I can take the in-class assignment same day. So from now on, just be aware of this. It can happen. I will decide on last in class, no problem. But
So
I
if
will.
you announce at least one class before one class, then
No,
it
in
will be
that case,
easier
you
to
are
us.
not participating. That is the problem. If you don't participate in the class, then how can you understand?
Sir,
If
we are
you
participating, but actually I cannot concentrate full time. I have some
okay,
problem
I will
like
see. I will see.
headache.
Some of the class assignment will be in class. Some of the, like I have announced today, some of the class assignment I will give. But in any case, I will not give you an assignment that I did not complete in the class. Okay, and if I take in class assignment, the question will be easier if I announce than if I announce before. So just in any case, that will be I think the same will be the process. The, I think, easiness or hardness, it will be the same. Don't worry about that. When I give the in-class assignment in the same class, I will give you easier problems.
So, but
Try
I did
to.
not complete that before in the previous class.
Okay,
the
no
class
problem, no problem. I might take one more. Don't worry about that if you are serious. But if you are doing the same thing again and again, then you will suffer. But if it is in case of one or two, I think that will be fine. If you are serious, just prove that you are serious in the class. That's what I want.
Yes, sir.
Okay.
Yes, sir.
Thank you then. See you in the next class. সবাই ভালো থেকো। আল্লাহ হাফেজ।